Hello everybody, this is Julian at Mecanum. So today I'm going to present you our QMA system, so Quasi-static Mechanical Analyzer. With this system you will be able to measure Young modulus, Poisson ratio, and damping loss factor of acoustic materials following ISO standard. Basically it comes with the main unit in which you will install your samples. Also come with a series of accessories, so compression plates of different size to compress your samples, verification gauge to calibrate your laser, also a verification sample, and centering tools to make sure that your sample are well centered into the test area. This is very important. Also, when you will receive your QMA at your lab, it is very important to make sure that it's installed on a very stable surface, such as a laboratory marble. So now that you have a very good idea of the test setup, let's make an example. I'm now in QMAX interface. I will start with the creation of a new project. Okay, so now the first step is to calibrate the system, verifying the laser and also the stiffness. So I simply follow the step that the software tells me. I will now measure the verification sample. And now I can verify that the result obtained by the equipment give the same thing as my certificate, or at least is within the tolerance. So I'm now ready to measure a sample. So now I will click on Add Measurement. And I will enter the sample dimension. So we'll start with the 44 millimeter sample. Install the sample. It's very important that my compression plate is well centered on my sample. So we measured our first sample. We can now remove the sample from the test area. And for the QMA, it's very important to test different shape factors, so different size sample as described in the standard. So I will now test a 29 millimeter sample. Again, I will click on Add Measurement. millimeter. I can add a sample description if I want. Here I will leave it blank. Again, I install the sample using the centering tool, very important. I start the measurement. So when the system is measuring a sample, it's very important not to touch the table, to make sure you don't make false measurement due to the vibration of the table. So now we've finished tested the second sample, and for the matter of the example, we'll test a third sample of 100 millimeter. So now my measurements are over. I have 3 samples of 3 different diameters. That means that I have 3 couples that I can compute to extract the Young modulus, Poisson ratio, and damping loss factor. So here I measured melamine foam. So I will use the general foam module, but if ever I have a fibrous, I can use fibrous. Or if I don't want the software to compute the Poisson ratio because I already know it, I can use the user-defined Poisson ratio. Here I will leave general foam. If ever I have a frequency that did not work very well, I can remove it with those two boxes here. But here I can see that my results are very flat, so very nice. So I will probably get very good results. So I will compute, and here, as you can see, all my results are green. It means that I have a very good correlation in my results. If ever you test more complicated sample, it can happen that you get a yellow box. It means that you have a not so good correlation, and if you get a red box, it means that you have very poor and you should test more sample to average your results. So as you saw in this video, the QMA system is pretty easy to use. You just need to follow the instructions. You will be able to measure Young modulus, Poisson ratio, and damping loss factor following ISO standard. So thank you very much for listening. I hope this video was useful for you, and see you in the next Mecanum training video.